So in this unit we're going to look at a system of equations, and a system is a set of equations. For our purposes it's going to be two equations with two different variables. And what we want to do is to solve a system, which means to find the values of the variables that make both equations true at the same time. So in this example here, which values of x and y, the same values of x and y, can you plug into both that will make both of them true at the same time? And in this case, x equals 2 and y equals 4 would satisfy both. You can substitute them in to see that. 2 times 2 is 4, plus y is 4 would be 8, and 2 minus 4 would be negative 2. So our solution set is the ordered pair 2, 4. Now one method for solving a system is to graph both equations and look for the point that they have in common. So let's just take the example from above and let's solve it by graphing. So let's graph these two equations. Lots of ways to graph equations. One way would be to arrange this equation into the form y equals mx plus b. So we can see y equals mx plus b, the slope is 1 and the y-intercept is 2. Alright, so y-intercept is 2, up 1 over 1 continuously, give us a graph looking like that. Now let's graph our other equation. Just to do something different, I'm going to calculate the x and y intercepts this time. To graph, I can graph it anyway, but this is one way. If y was 0, 2x would be 8, so x would be 4. So 4, 0 would be a point on the graph. And if I calculated the y-intercept, which means that x would be 0, I'd have 2 times 0, or y would be 8. So 0, 8 would be a point on that graph. Okay, and if I connect that, my graph looks like that. So we have two graphs. We have a relationship between x and y. The graph is showing all the points x and y that satisfy this line, this equation. This line shows all the points that satisfy that equation here. So to solve the system, the points that satisfy both is the point of intersection, which is right there. And if I read that off the graph, it's 2 over 4 up, and indeed my solution set is 2, 4. Alright, here's an example, and we're going to use a system of equations to solve this problem. We have a stage that's rectangular. Okay, there's our stage. It has a perimeter of 158 feet. The width of the stage is 31 feet less than the length. Write a system of equations to determine the length and the width, and then solve the system graphically. Alright, so we're being asked to calculate the length and the width, and what you're trying to find is always your indicator of what your variable should be. So I'm going to let x be my width, I'm going to let y be my length, and since I have two variables, I'm going to need two equations in order to solve this problem with the system. So in the first situation we have a perimeter of 158 feet, so if we add up the four sides, which would give us 2 x's plus 2 y's, that will be 158. And then we're told that the width x is equals, it's 31 feet less than the length. So if we were to take 31 feet off y, take y and subtract 31, we would get the width. So there's our system, which we are now going to solve graphically, and I'm going to solve this one graphically using a calculator. Since the numbers are bigger, the graph would be a little bit more difficult to make accurate on paper by hand, so I'm going to use a graphing calculator just for accuracy purposes. So if I'm going to use a graphing calculator to solve my system, I'm going to need to have y isolated in both of my equations, because when I enter an equation in the calculator, it has to be of the form y equals. So for equation 1, I'm going to subtract 2x from both sides, divide by 2, and that would be 79 minus x, which is equation number 1. And then with equation number 2, I'm going to move the 31 over to the other side. So that's going to become y equals x plus 31. So here are my two equations. On my calculator, I'm going to enter that into y equals. So that's going to be 79 minus x. And this is going to be x plus 31. Now the other thing I've got to think about is my window dimensions in terms of having this all show up properly. My horizontal axis, I'm just going to go to my window setup, and I'm going to label x, remember, represents the width. Well, the width couldn't be any smaller than 0. So I'm going to make my, instead of my x minimum 0, I'm going to make it just slightly less than that. Sure, let's go with minus 10. And the biggest width, keeping in mind that the perimeter is 158, if all of the perimeter went into the width, that would be half the perimeter, so that would be 79. So I'm going to make this about 80. And I'm going to do similar for the length. So negative 10. So I'm making it negative 10 just so I can see a little bit below y equals 0, the x-axis, and going up to 80. Alright, so I graph my lines and I can see the point of intersection. Now to get the point of intersections precisely, if you trace, the problem with tracing is that you might not know or be able to get right on top of the point of intersection exactly, precisely. So the calculator has a handy dandy feature that will land us exactly on the point of intersection of the two lines. If you go to second trace, which is the calculate menu, go down to number 5, which is intersect, you're going to get asked 3 questions. First of all, you're going to get asked, what are the two graphs that we're intersecting? Well, in this case, we only have 2 graphs. Y1, which you see in the top left-hand corner, is showing, and the cursor is showing on that curve. Yes, Y1 is one of the curves that I'm looking to intersect. So let's press enter. Y2 is the second curve. Yes, it is. And guess is, just bring your cursor close to the point of intersection, press enter, and we get the exact point. X is 24, Y is 55. X is 24, Y is 55. And if you substitute both these values back into these two equations, they will satisfy both equations, in fact, and so we know therefore that the rectangle width is 24 feet and its length is 55 feet.